When we started our discussion of graphs, we said that we utilize statistical graphs to look for features that reveal some useful or interesting characteristics of a data set. Well, why do we study bad graphs? We study bad graphs so we can critically analyze graphs to determine if they're misleading. Not all graphs are properly designed, and it's important to find out what makes them misleading so that when we see a graph, we know what questions to ask about it, what we're looking for. The designer of a bad graph is not necessarily trying to mislead us. It may just be unintentional. But either way, we want to be able to determine if we should trust the information we're seeing or not. So we're going to look at two ways graphs can be misleading, and the first one is what we call pictographs. And these are drawing of objects used to depict data or symbolic figures that show frequencies, the counts, how many of different kinds of statistical data. So we'll keep that, and let's look at an example of how pictographs can be misleading. So they're interesting. We can see here we have a graph of the number of adult frogs in South Pond in May, and then again in September. And instead of putting a bar there maybe to represent the height of the bar and the frequency, we have an interesting drawing of a frog. So in May it looks like there were 10, and in September 40. So in September we would say there were 4 times as many, but if you're not careful and you just look at the pictures, the second frog, the September frog, is much bigger than the first frog, much more than 4 times as big. So visually it doesn't represent what the numbers are actually telling us. So this type of representation can lead to the distortion in the relationship of the values in the example here, or in our data. Okay, the second way graphs can be misleading is when we have a non-zero axis. So let's look at how that would look. This is an example of median household income in 2010 inflation adjusted dollars. So for these 11 years, 2000 to 2010, they've recorded the median household income all adjusted for inflation to 2010 dollars. So if you look at the highest median income, which occurred in 2000, $53,164, and compare that household income with the very smallest, which occurred in 2010, about $49,500, right? So the difference between the highest median income, about $53,000, and the lowest, $49,500, is $3,500. Now that's not insignificant, especially to the people making this money. But if you look at the bars, it looks as though 2000 was, 10 times as much as 2010? If we just look at the bars. Now why does it look like that? Because we're not starting at zero. We have a non-zero axis. And so when we do this, it leads to exaggerations between the differences, especially in a bar graph, because we see that the top of the bars are to the far right of the bars. If it was vertical, we'd say the top. Horizontal, we say the right. The difference is much more dramatic when we do not start at zero. And so let's look at this same chart if we do start at zero. And notice that to the right, it's not as dramatic. The difference between 2010 and 2000 is not as dramatic. Now I'm not saying that there's not a difference. There is a difference, and I'm not saying it's not a concern that median household income appears to have dropped. But what I'm saying is that using a non-zero axis makes that difference much more dramatic than if we start at zero. So Pictographs and non-zero axes are two of the bad graphing methods we want to be aware of when we study statistics.